he will be missing.
Yeah, okay, okay.
Okay. Okay, so today we'll learn about Terraform. For that, just let's learn about some few topics. Okay, so this we can skip. Okay, yeah. So what is infrastructure as a code? Okay, so we know we till now whatever we used to do like in VirtualBox or in AWS or in Azure, we log into the console, okay, and we create the VMs or any other resources, okay, manually. Manually means we log in and then we create by doing next or some other methods. Okay, but instead of logging to the console and creating the resources manually, it is also possible to create the resources automatically using code, and that is called as infrastructure as a code, provisioning and managing the IT infrastructure using source code. Okay, rather than doing the standard operating procedures and manual processes, that is infrastructure as a code. So Terraform is one of the infrastructure as a code. Ansible is one of the infrastructure as a code. Those two tools we'll be using to create the infrastructure in this course. Okay. So we also need to understand few terms like deployment, provisioning, orchestration, and configuration management. So when we say deployment, it means we are deploying something. So mostly this deployment term is used with respect to application. So till now we have deployed application using docker run command, kubectl run command, kubectl apply command. That was the deployment of the application. And what is provisioning? Whenever we create a new VM, okay, or any new resource is created, okay, on top of which we'll be doing some other configurations, that is provisioning. So whenever we say I'm not we should say I'm provisioning a VM. We should not say I'm installing a VM. We should say we are provisioning a VM. Okay, and installing means after provisioning the VMs, if we are doing any installation, okay, in terms of VirtualBox, not in cloud, that is installation. But we should always say in terms of cloud, I'm provisioning a VM. Okay, and orchestration. So orchestration is nothing but Kubernetes, Terraform. These are our orchestration tools. They help us in orchestrating the various managing the multiple system, that is orchestration. And what is configuration management? After provisioning, so we have provisioned the VM in cloud, we have created the VM. Now we need to install something on it, or that is configuration of IP addresses, host name. Okay, all these things are config management. So two important terms are provisioning and config management. Provisioning means first time when we create a VM or resources, that is provisioning. And after provisioning, whatever we do for the configuration management, that is for managing the configs and all, that is configuration management. So Terraform is one of the provisioning tool, and Ansible is one of the configuration management tool. So mostly first we provisioning the infrastructure using Terraform, and after provisioning the infrastructure, whatever installation we do. Okay, so installation means installing Apache server, Nginx server, or installing Docker and all, that will be part of the config management. Okay, but they can also be used interchangeably. We'll talk about that later when we start Ansible. So there are two more important terms. One is immutable and the other one is mutable infrastructure. Mutable infrastructure, short definition is we can change it anytime. Okay. Okay. We do not follow any proper procedure and we can change it abruptly anytime. Okay. And due to those changes, there can be a downtime. There can be a configuration drift. Okay, and that can result into bugs, and it may be difficult to diagnose and reproduce. Okay, that is mutable infrastructure. Immutable means which cannot be changed. When we say which cannot be changed, it doesn't mean that we cannot change anything. It means with respect to the application. Suppose an application is deployed, okay, version 1 is deployed, okay, and if you want to modify that application, then we should not modify the live version 1. We should create a version 2 of it, and then we should deploy it. That is immutable infrastructure. Okay, so nowadays immutable infrastructure is what recommended everywhere. two more terms, imperative and declarative. Imperative means will give step-by-step process of how to achieve something in terms of configuration or software, and declarative means we won't give step-by-step procedure. We'll just say to the system achieve this anyhow, means we'll tell the system that I want this desired state. So what the system will do, it will check what is the current status and what is desired status, and it will try to achieve it anyhow. So again, I'm repeating, imperative means giving step by step instructions, whereas declarative means we will just define something, will declare that I need this and it will achieve it. So for achieving, it will compare the current and the desired state. And one of the important term is idempotence. Okay, so it is also a principle of infrastructure as a code. So what does that means? Once we deploy something in the infrastructure, and if we want, suppose I've created a VM, okay, and I try to create run that using some code, and I rerun that code, so that it creates a VM, but VM is already created, then it will not retry to create that VM. It should not touch anything. Okay, but if the system is not idempotent, then it will try to recreate it. Okay, so idempotency means don't retry to create, means retry it but don't really try to create that. So it happens in scripts. Okay, suppose in script I have created a file, so when I try to again create a file, it should skip it. It should say it already exists, it should not try to recreate that. That is idempotence. And what is Terraform? Terraform is idempotent, it is declarative in nature, and it helps us in creating an immutable infrastructure. And these are all the properties of infrastructure as a code. Okay, so that's why we learned about all these terms. So achieving anything using code is done with the help of Terraform. So it is HashiCorp's product. HashiCorp means it is the company who created Terraform. The HashiCorp is very famous. They have some other products as well, like Vault, Console, Nomad, and all. Okay, so let's learn about its advantages. We know that it helps us in creating the infrastructure using code. And when we go to the cloud, okay, in cloud, for creating the infrastructure using code, in Azure there are ARM templates, in AWS there is a cloud formation, and in Google there is deployment manager. So suppose if you don't know about Terraform, then in Azure we'll have to use ARM templates. Okay, suppose after few days we are using AWS, then again we'll have to learn about cloud formation. And after a few days again, if you want to learn about Google, then we'll have to use deployment manager. In short, in 6 months of time we'll have to learn three different types of infrastructure as a code. They have different syntaxes and all. But if you use Terraform, okay, it supports almost all the clouds: AWS, Azure, GCP, DigitalOcean, OpenStack, OpenShift, okay, even VMware it supports. Okay, so just learn Terraform, and then we do not have to learn any cloud native infrastructure as a code. Okay, it helps us in creating immutable infrastructure. Okay, it is easy to understand when you see the code. It uses HashiCorp configuration language. Okay, HCL it is called. So that is also very easy, human friendly, and we can reuse that code. So once we learn about Terraform, the same logic we can apply on any type of cloud, on premise or cloud, but provided that it is something is created for that particular provider means for AWS, Terraform has a separate provider. For Azure there is a separate provider. That means to interact with the this clouds using APIs, okay, Terraform has created some providers that we'll be learning when we do practicals. Okay, so these are the advantages of Terraform. We learned that Azure, AWS, Google Cloud has different types of IaC or provisioning tools. Okay, but it is easy to learn Terraform, and we can use we can learn only one Terraform and apply it everywhere. Okay, so Chef, Ansible, Puppet, okay, they can also be used as infrastructure as a provisioning tool, okay, but they are not meant for it. Ansible, Puppet, and Chef, they are meant to for a configuration management. It is possible, but the main purpose is they are used for configuration management, not for provisioning. So Terraform lifecycle is important. So what it involves, it involves initialization. So initially we'll be using Terraform init command. Okay. So when we do init, it will check the provider. It will download the plugins required for the uh, means interacting with that particular provider. So suppose we are interacting with AWS. So when we do Terraform init, it will download all the plugins required to interact with the AWS. Then we will do Terraform plan. Plan means we'll check what we are going to provision, which new resource we are going to create. Okay. So once we test it, we'll apply that plan. Okay. So we'll be using Terraform apply, and at last, when the means not always, but when we see that our apply means infrastructure is created after Terraform apply, if we want to destroy it, we can also destroy it using Terraform destroy. So every day after creating the resources, when we see our exercise is completed, we'll be using Terraform destroy command. Okay. So how does the whole structure looks? So we will be creating some Terraform files, .tf files, okay, that will have our infrastructure as a code, proper code. Okay. So and we will have a Terraform state file. It also gets automatically created, which keeps the track of desired and the current state of the uh, resources which we are creating. So in this case, suppose if we are creating AWS resources, we will create a configuration related to creating that particular AWS resource. In .tf file, suppose ec2tf main.tf or s3 bucket.tf. Okay, so it will create a tf state file after creating the resource. The tf state file has all the details of what is created. So next time when we try to create again, it will refer the tf state file whether that resource was already created or not. If it was created, it will skip it. Okay, that is the idempotency behavior. If it is not, then it will recreate. And due to some reason, if you comment anything in .tf state file, or if you delete that tf state file, so it doesn't have any reference, and it will try to recreate it. Okay, so the tf file is very important. So that was a short theory about Terraform and infrastructure as a